Hello, welcome to our practical astronomy evening. Tonight we're going to try and bring you some live views from two telescopes here in Nottingham. The weather looks promising so far this evening, so if we get all the technology to work, we hopefully have some live views of the planet Jupiter shortly. Currently in progress, Io, one of its moons, is transiting across the disk of Jupiter, and we've shortly followed by the shadow in about 15 minutes time, so we'll hopefully be able to witness that event this evening. So stick with us. There's an awful lot of technology that can go wrong, but we'll try and see if we go live to the Nottingham Astronomical Society Observatory site in a few minutes time. Also joining us this evening, Julian is going to talk to us about the recent announcement of the detection of phosphine gas in the cloud decks of Venus. That announcement was made earlier this week, and Julian's going to talk a bit about that. So if you have any questions, do please send those in to Julian. So we'll see how this evening progresses. Just a quick reminder, our October meeting is on Thursday the 1st of October at 8 p.m. and we're going to be joined live by Dr. Steve Barrett for a talk on the Hubble Space Telescope. So whilst we get the telescope set up and just wait for the skies to get a little bit darker, we're going to start with James going through a quick demonstration of his new Skywatcher EQ8 mount, and he's going to be using that this evening to provide the images. So the EQ8 mount is Skywatcher's latest addition to the market, and it's their first really observatory class mount, but still has the same functionality that most of us are used to with the Skywatcher handset. So over to James for a quick introduction of the Skywatcher EQ8 mount.
So this is a talk on my new Skywatcher EQ8R Pro mount. This is the short version in case the weather's nice and we want to spend more time looking at things in the sky than listening to Death by PowerPoint. This mount comes with little feet. These are adjustable. There's a screw mechanism to alter the height. This dissipates the load of the tripod and the mount over soft ground. So once you've polar aligned, your mount isn't slowly sinking into ground, and they're very effective. Lie them out traditionally with one foot, one leg of the tripod towards the north, two at the south. Here we have the tripod on these feet. The tripod weighs 30 kilograms, so it's pretty heavy. The whole setup is heavy. There's the pointy bits of the tripod, sits in these little cups. It doesn't look stunningly stable, but it really is. It's a very clever design. On the tripod itself, this central column is adjustable with these nuts here. You can alter the height. You can go. The height of this can be 80 centimeters above the ground to 110 centimeters. So that's 31 inches to 43 inches. So you adjust this height, whatever you want. The column itself isn't resting on the ground. There's a couple of inches beneath the bottom of it in the ground. The tripod is taking all the weight, and these arms just help stabilize things. On top of the tripod, it's got these Teflon pads which help the rotation of the mount head on the tripod. The central, or rather this pin, is for the azimuth bolts to push against for polar alignment, and it's got a central bolt here which fixes the mount head onto the tripod, as with most mounts, but unlike other mounts where you put your hand underneath, there's a knob at the side here and there's some gearing inside. So you rotate this and that rotates that bolt, and we'll screw it into the mount head. This is also spring loaded. There's two threaded holes here which we'll have a look at shortly. This is again looking from the top, and remember, as I didn't the first time, that little pillar post needs to be on the southern side of the tripod, not the north, which is the convention. So I've put the mount on the tripod now. The mount itself weighs 26 kilograms, and there's a threaded hole that we saw in the tripod, and there's a groove here, and what you do is drop in a hex nut and screw that down with an Allen key to provide additional support to stop the mount head from falling off the tripod. This is an observatory class mount, so it's not designed to be lugged out every night. That's why there's a few more steps which make it better to be a permanently set up mount. Here's one of the azimuth polar alignment adjusters, and you can see these azimuth bolts come in and will push against the peg which is there. There's a little bubble level on the base of the mount head, so if you want to get the mount level you can adjust the feet to do that. And then here's looking at the mount head. Here's the saddle that the telescope will slot into, and the nuts to tighten that up. The clutches are, there's the clutch for the deck, and there's the clutch for the RA. There's one of the azimuth adjusters, and here's the altitude adjustment bar. And these knobs here release tension through this axis to allow you to make adjustments in altitude. There's no polar scope, but there's you can get a bracket with a polar scope on, or the keen-eyed might have spotted I've put my Polemaster adapter on. On-off switch, conventional power for the modern Skywatcher mounts, hand controller. I'm going to skip over lots of the other bits for this short version. There is a longer version which Richard will put on the channel. Here is the counterweight bar. That's 2.6 kilograms on its own. That screws in. The counterweights are 10 kilograms each, and it comes with two. Here's the power lead, conventional again, cigarette socket that end, 2 pins there, handset, Ethernet lead. That's my little mobile power supply. The mount itself doesn't draw a great deal of power, half an amp when it's tracking. And there is the C14 on the mount, so this will be the setup I'll be using on Thursday to look at Jupiter and Saturn. And hopefully you'll see a quick video of the mount slurring with the scope on. It's remarkably quiet. It's got belts in both the RA and the deck, and it's a lovely item. So there is a slightly longer version with a bit more detail. I'm not an expert on this, but we'll get a link to that. Thank you.
Thanks, James, for the demo on the EQ8. I noticed you didn't say how expensive it was. I'll let people look that up online if you want to take a look. So a bit of frantic action behind the scenes to try and set up the telescopes. I think up at the observatory site, they're making a bit more progress than me down here. I don't get views of Jupiter probably till about another 20 minutes from behind the neighbour's house. So we're going to try and link up with Leigh and James up at the observatory site shortly. Just a quick look at the setups that we've got tonight. And so this is the view just taken an hour or so ago up at the observatory, and that is the C14 scope that James has got set up on his EQ8 mount. So he's now just on Jupiter. We're just waiting for the sky to get a bit dark. We're struggling a bit with the contrast with the skies at the moment. The seeing isn't brilliant this evening, but we'll stick with it. We're going to sort of have quite an informal evening tonight. So first thing I'll say, if you do have questions during the evening, we're happy to take those as we progress tonight. So do put those in the live chat. Outside my back garden, that is my setup. That's taken looking straight down from my window of my scope and mounts. That's a Celestron C11 mounted on a Skywatcher EQ6 mount. I don't have a very good view of the sky at all. I'm completely blocked by my own house to the west, quite limited to the east. The southern horizon reasonable, but the planet's quite low, so I'm just waiting for Jupiter to appear out from behind the houses. So we'll hopefully link up with that a little bit later on. And also we'll be joined later by Julian. He's going to give us a talk on the recent discovery of phosphine gas in the cloud decks of Venus. So that's the general arrangement for this evening. So let's see if we can pick up the team up at the Nottingham Astronomical Society Observatory. So I don't know if Leigh and James are able to unmute. I think first of all, I don't know what sort of stage you're at up there, but if perhaps, I don't know, Leigh, you able to give us a quick view of Stellarium, of what we can actually see in the night sky at the moment?
I certainly can.
Excellent, cool. Right, I'm going to try and allow you to share the screen. So I'm going to make you host. So hopefully you should now be able to take control and show us your desktop as Stellarium. Sorry, I was going to do that myself this evening, but my Stellarium isn't playing ball.
Okay.
Cool, that looks perfect. We can see that nicely here.
Marvellous. Right, so yes, if you've got a good view to the south at the moment, our two largest planets are quite well placed. Not as high as to be nice to be, but quite nice and close to each other. If you've got binoculars or a scope, good time of year at the moment to get out there.
So Jupiter and Saturn are getting quite close, aren't they now? So we think we get the closest sometime late December, which I think the closest they've been since 1623 or 1625. So that will be quite a treat to see later.
Just to give it some context of what else is in the sky at the moment as well. Switch the constellation lines on there and the labels. So just looking a little bit higher up into the sky, you can see we've got Altair and making up this summer triangle. There's Cygnus and Vega in Lyra.
Is Mars up yet? That's about rising around now, is it? Over in the east side?
Let's just have a look.
Must be pretty close. Perhaps not quite yet then.
Well, we can wind that on a little bit and we can tell you when that's up. No.
Probably about 9 o'clock then, perhaps.
There we go. Yeah,
there we
go.
So Mars is getting pretty close to our position sort of towards the end of October, about October the 27th, I think. So it's getting bigger and bigger all the time. So hopefully we should get some good images of that towards the end of October.
Yes, and it should be getting quite high this year as well. So it's I'll let that continue on. You can see, still a bit getting quite late at night this time of year, but as we progress, it should get better. I see it gets quite high up in the sky. So looking there, let's just see how many degrees up. It's 2 in the morning for those of you that are more keen. There we go. So that's 45 degrees at 2 in the morning. So yeah, it's pretty good.
Not bad from the UK.
No, not at all.
Okay, one thing we were hopefully going to try and have a look at this evening is Io. So Io's currently over the disk of Jupiter at the moment. What time is it now? The shadow transit, so the shadow of Io cast by the sun onto the disk should be about starting to enter onto that. So I think we may struggle tonight to see Io itself on Jupiter, but perhaps we might have a bit better at its shadow. It's quite a big contrast there, so it'd be interesting to see. I don't know, is James any thought? Can he pick that up yet, or is it a bit too early? I think it's probably just about to start.
Yeah, let's get that. Do apologise for clunky movement there, but I'm on the no mouse.
The fact this is working up there on 4G in itself is impressive.
So there we go. So as you can see, there's Io. This is the view as it would be now. So if you've got a telescope on there, Io's bang in the centre almost, and there's a shadow just encroaching on the west side there.
I don't know if James can hear us online. Any luck with picking that up yet with the telescope views? Can't quite hear him yet. I don't know if he's still on mute.
He's, yeah, he's just reporting back that the seeing is awful at the moment.
Right. Okay, fair enough.
The view, looking at the view over the city, there's a lot of haze.
Yes.
You know, a lot of haze. I suspect the heat of the day is still rising at the moment. So.
Yeah, red spot, if anyone's interested. I think it's just rotated off the disk at the moment. It's just off to the...
It's on the east side there.
Yeah, that's always quite an interesting one to try and see. Is it worth us having to flick over to Saturn, see what Saturn looks like at the moment?
Yeah. I'll just right back out. There we go.
So Rob Bush has just said he's got good views of Jupiter in his scope at the moment. So shame you haven't got a webcam, Rob.
Well, it's pretty windy up here at the observatory, and the seeing's pretty poor. But I can show you what we are looking at when it's time.
Yeah, we're good to go whenever you're happy. So there's Saturn. We hopefully pick Titan up there. We'll see if we can get that on the DSLR or not in a bit. It'll be a while before it gets visible from my C11, I think, Saturn, but we'll give that a go in a bit. If not, we did take some images of it on about Monday, Tuesday night, so we'll show those if we can't get any decent seeing.
So.
Is there any more you want to cover, Leigh, on the...
Let's see. And other things be able to see at this time of year. Yes.
If not, we can try and see if we can share James's screen and see what his views are like at the moment. James, do you want to talk a bit through about your setup at the moment, what cameras you're using?
Yeah, can do. Have you got that image again that I took earlier from the observatory of the kit?
Yeah, let me just reclaim the host to share that.
We need a thermometer at the observatory and a wind gauge. Although having said that, I think the wind has actually just settled down a bit now. A lot more stars are coming out. I can see the summer triangle above. And beneath that to the south, I can see with naked eye Jupiter and Saturn. No sign of Mars yet. And that must be Arcturus over there, yeah, and the plough.
Okay, so we should have your setup now on screen.
Yep, so this is the EQ8 that you've all seen the video about. And we've got that polar aligned. Even with Planetary, it's very helpful to be polar aligned because you want your tracking to be as good as possible, and especially when imaging with the planets, you need the the planet to stay on the sensor. And the sensor's pretty small, so the more accurate the polar alignment, the better. The other thing that's important with planetary work is the collimation of the scope. Now, with a refractor, the collimation is seldom a problem unless something dire has happened to that scope. But with reflecting telescopes like Newtonians and Schmidt-Cassegrains, where there are mirror elements, that they need collimating. And Damien Peach talks about collimating every time he sets up, because it's that important. And it must be that easy if he does it every time. So you can see at the front of this Schmidt-Cassegrain scope, there's a big glass plate. That's the corrector plate. And if you look at the back of the tube inside, that's where the mirror is. And in the center of the corrector plate at the front, in the middle of that glass sheet, is a black plastic ring. And on the far side of that is another mirror, the secondary mirror. And on the outside, you can see there's 3 knobs, and those are the knobs that you would use to collimate the scope. And they push on the secondary mirror behind them and alter the angle of that mirror. And the idea is to have perfect collimation, so your out of focus stars are they have nice concentric rings about them. So the scope needs to be well collimated, needs to be well cooled. These are big lumps of metal, and so if you have them in the centrally heated house, they'll absorb the heat, and then when you come outside, they start radiating the heat, and that can take hours for that heat to dissipate. And while it's dissipating, it produces lots of waves, heat waves, which can distort the image. Also there, I've got my laptop set up. That's connected to the camera, which is on the back of the scope. I'm using an ASI ZWO224MC, so color CMOS camera. It's got quite a big chip, and it can achieve quite high frame rates. I think about 250 frames per second. And that's useful when you've got an image like a planet and the seeing is poor. And we'll talk about that another time, I think. The seeing is pretty poor tonight. You can't see, but I'm now looking at the image of Jupiter live on my screen. Daddy Longlegs is trying to help as well. And many of you will know what the seeing is. It's everything between the sensor of the camera and the planet. So things like the collimation and the temperature of the scope and the quality and the cleanliness of the optics will impact on the view. But also we've got local factors. If we were looking over the top of houses, those houses would be radiating heat and distorting the view to the planet. And the biggest factor is the atmosphere. So the jet stream is the biggest problem for us in the UK. It often sits overhead and distorts the image for us. Richard, are you able to give me the screen to show the image I've got of Jupiter?
Yep, so I'm just giving you host, so you should be able to share your screen now.
So hopefully, can you see
Yep,
a cream-coloured ball?
Yep, that looks fine to me.
Well, it's not fine.
It's not a Damien Peach, I'll give you that. But there we go.
Oh my
We got
goodness!
to manage expectations.
So, I'm using software. This is called SharpCap, and I need to cough, so I'm going to go on to mute. I'm back. It's called SharpCap, and it's taking the feed from the camera, which getting the image of the planet onto the camera and then that into the computer. And this is a live view of Jupiter. And I've aligned it so the bands of Jupiter are running left to right. Hopefully, if I make it smaller, it often sharpens the image up. Or maybe it doesn't. Let me have another fiddle with the focus. Now with this Schmidt Cassegrain especially, when you alter the focus, that looked good there. The primary mirror moves, and that can cause the actual image to shift a bit, which is one of the limitations of this type of scope. No scope is perfect, but hopefully you can get a hint. Let me just alter some more settings. I'm trying to get it optimal as much as possible. Hopefully you can get a hint that there's a band here and there's a band there, and then the poles are here and here. And I've loaded Stellarium up. Can you see Stellarium? Hopefully. So this is what it should look like, and there is IO, and so we're really looking for one of the moon's IO about here, but the seeing's just too poor to resolve that, and then the shadow would be coming in over this side. But this isn't an uncommon view in the UK on a poor seeing night. Actually, looking through the eyepiece, the view was much better, and it's a shame I can't show you that view. As Jupiter continues to get higher, it will get highest when it is due south, which must be pretty near looking where it is. The seeing gets better because the atmosphere is thinner, and also as the telescope cools down, as it's quite cool here now, the seeing could get better. Often the seeing is very good just after sunset, and in the very small hours before sunrise, as sort of temperatures are stabilized, or there's no big gradients. But that's not an uncommon view. And what we do with imaging is to capture this data, a couple of minutes worth. How many frames per second? So currently it's doing 82 frames per second. So if we were to do a capture, number of frames, so time limit, so we could change that to, we could just do 1 minute. Time limit, and if we're doing 80 frames per second, it will do 80 times 60 frames. So here we've got the number of frames it's capturing in this 1 minute exposure. And this produces a video, an AVI file generally. and that video is made up of all of these frames. So Daddy Longlegs is back. 2,500 frames in 30 seconds. So we're going to have about 5,000 frames. And then stacking software, I won't go through that now, breaks that video down into individual frames, studies each of the frames, looks for the best ones, which would be very difficult tonight. And then the user can pick the best ones and put them through stacking software, and it brings out better resolution. Let's have a
often known as
lucky imaging. So this is the video we've just captured. It's playing it at a slower rate, but this really demonstrates the problems with the seeing. You can see the whole planet is rippling. It doesn't look like a spherical ball all of the time. It's buckling and boiling, and this wouldn't be a good night to try and get your Damien Peach quality image, but this is reality. So a quick look at Sharp Cap. With this sensor, I can this is the sensor at its full size, which is 1024 by 768 pixels, and that's how big Jupiter is. Now, in a scope with a much shorter focal length, Jupiter would be much smaller. So with the C14, it's pretty good at producing a large image of Jupiter on the sensor. And with this sensor, and when people say sensors, they mean the chip inside the camera. So we can alter how much of the sensor we want to use. And you can see on the right, this black box, this is the whole sensor. And the region of interest, I can pick any of those. So if you've got a lot of dust over this side of the sensor, you could choose to image somewhere else on that chip. And when you're using a smaller part of the sensor, there's less data to transfer down the USB lead, so you can get quicker frame rates. So if we go back to the full chip, we're getting here 80 frames per second. But then if we went really small, we're still getting 80 frames per second. Okay, that didn't work well. Here, look at this one first. This is gain. This is like ISO on a DSLR camera. It's how much you're going to boost the image you're getting. And for imaging, you generally have it pretty high. But experimenting tonight to show you a nice image, it's better to have it quite low. And then this slider is the exposure, so it's like the shutter speed on a DSLR. And it's just a case of finding a nice compromise. For experienced people, you can use the histogram to decide where you want your peak to be. But I think most people just do it by eye. If you have the image too bright, you burn out all the detail. So if we recorded data like this, we just end up with a white blob. But if we record at this end, we just end up with a grey blob with no detail. So it's a case of finding a happy medium. And I think the seeing is steadying a bit. Those bands are coming out a bit more. And then I don't think we need to talk about any of the other bits. So what I'll do, I will have a fiddle with the focus and see if I can get that better. And if not, I might just slew to
Saturn and see what that's like. Richard, are you there? He might be fiddling with his C11 to try and get Jupiter in his scope. So I'll have a fiddle with the focus. And as usual, you always forget something, and I forgot to bring a 9-volt battery. So my electric focuser isn't working, so I'm doing it by hand. I just hope Damien Peach isn't watching. Are we getting letters of complaint? How can you do a tutorial on observing planets without an electric focuser? No, I'm struggling to make that any better. Julian, are you there?
Yes, I'm here.
Are you enjoying the views of Jupiter?
Yeah, and I'm seeing more bands.
Yeah. The wind keeps picking up, which isn't working in our favour, but as I say, that is life. Now let's see where the shadow should be. My poor computer. Okay, so it says the shadow should be there, and I just wondered, Julian, do you think that you could see anything there?
I have to say I can't really see much there. No. Not even with wishful vision.
Oh dear. Okay. Well, I might move to Saturn. We need Richard really to move the host from me to you, Julian.
Yeah, I'm just back, so I can do that now. I'm not far off from having view from mine actually, but
what's the view like?
Not great. No, I can't. I can't see.
Oh.
I can't see IO at all on the disc. That's a shame.
I think I can see something. Leigh's pointing at high speed mode on. Just makes it more great. Well, I think there's something there. We'll come back to it. Richard, I'm going to go to silent and move to Saturn.
Okay, no problem. So, Julian, at this point, are you happy to take over and tell us a bit about what's happening?
Sure. Yeah, I've only got
the phosphine gas.
Yes, I've only got about 10 or 15 minutes at most, so that should give you plenty of time to align on Saturn and sort things out.
Excellent. Good. So,
Okay.
so if we can jiggle around this host, I'm going to bring the host back to myself. Okay. So, Julian, you should now have control. So if you want to share your screen.
Right. Does that look okay?
Good. That's fine with me. Yep.
Oh, I just clicked on the wrong thing here. Sorry. Right. So good. So I expect most of you came across the announcement that on Monday, although it was leaked a little on Sunday, if you were observant, that they came up with the idea that there might be life on Venus. And I have to say, I really didn't see this coming. It's not something that was even on the wall chart, so to speak. So I thought I'd talk a little bit about this. Obviously, this isn't really my area of expertise, but been reading up quite a bit on it recently. So let's just get into it, and I'll tell you a little about it. I was lucky in that I happened to be on a sort of seminar with Sarah Seeger, who I'll mention in a minute, and that's looking back on it, there were a few hints dropped. Anyway, let's go on it. So where did the idea come from to go looking for this? Well, originally it came from exoplanets. So you know that exoplanets are planets around other stars other than our own, and they the latest thing is not finding them, because we found thousands of them now. The new great thing is to go and examine their atmospheres and look in particular for biosignatures. So that's signatures of things that you would expect if there was life on those planets. So they're trying to find life on the planets, basically. And one of the approaches, I mean, there's lots of approaches, but one of the approaches that Sarah Seeger, who is this lady here, who works at MIT, was looking at was to sort of turn it on its head, rather than to look at a planetary atmosphere and say, what can I actually see in that? Can I see, you know, take a spectrum of the planetary atmosphere, which is not particularly easy anyway, but then to go and look at that and say, what can I actually see in there? What sort of gases are there? She decided to turn it on its head and produce a sort of a combinatorial sequence of saying, what are all the possible small molecules that we could actually make out of just a few simple atoms? So carbon, nitrogen, hydrogen, oxygen, phosphorus, and sulfur, I think. And she sort of ran a computer program that could look through all these and say, well, what sort of combination can you get? You can get, you know, a carbon with 3 hydrogen, that's methane. You can get all sorts of other things. So she attached it from that position and said, well, these are all very simple molecules that could easily produced. Which ones do we know that are produced, and which ones do we know that are produced specifically by life? And you can see there she got 14,000 possible molecules, and produced this paper here towards a list of molecules as potential biosignature gases. So this is a whole list of things that might possibly be indications of life. And this led her to look outside the normal things. So normally we think of water, oxygen, ozone, a couple of other things, methane perhaps, as biosignatures. But she was sort of turned it on its head and said, well, what other molecules could be produced that we don't know how to produce in other ways? And that could be an indication of life. So she came across that. And during her talk, she mentioned phosphine as something they were looking for on exoplanets. And she seemed to dwell on it quite a bit. So I think that was dropping a hint that that was going to come up. Next person is Clara Souza Silva, and she spent her whole PhD looking at signatures of phosphine. So she was trying to understand how you would detect phosphine in atmospheres, particularly because it's present on Jupiter and Saturn. So James would have been looking at some phosphine there in the atmosphere of Saturn and in Jupiter. And also for exoplanets. So her whole PhD was how to sort of work out what the signal for phosphine would be if we found it on an exoplanet. And she's now at MIT also working with Sarah. So she was not expecting this to be sort of particularly taken up. And to get a call about Venus was probably also quite a surprise for her. So the next person in it is Jane Greaves, who was the one who was the principal author on this paper and the principal investigator. So she sort of got hint of these possible ideas that these are planetary signatures that could be found on other planets, showing perhaps that there was life on those. And she thought she'd use some telescope time she had on this JCMT on the left, James Clerk Maxwell telescope, works in the sort of far infrared, well, towards the far infrared millimeter wavelength. She thought, well, I could go and look at Venus for these sorts of things and see if I could find it there. And indeed, she did find it there, and that's what this announcement was about. She was quite surprised to find it, so she found it, I think, about a year ago. So as it would be under dispute from the scientific community almost immediately. She applied for time on this other telescope here, ALMA, which has much better resolution than JCMT, and got some time on that. And that also detected the phosphine. So between the two of them, it shows that it's not just one instrument, that she's found it with two different telescopes. And the analysis carried out seems to show it's a good solid signal. So what is phosphine? It's a really simple molecule. Here it is. There's a phosphorus and 3 hydrogens attached to it. So it's a bit like methane, but replacing the carbon with a hydrogen. And it's pretty simple, so which is why they picked it. And what do we know that can make phosphine? Well, we know Jupiter and Saturn can, but there it's formed very deep down under very high pressure, deep in the atmosphere. So that sort of environment can make it. We don't think Venus or Earth or any of the smaller planets has nearly got enough pressure or heat. Well, mostly pressure actually to make this. So that's why it wasn't expected, and why we don't really see it on the Earth either. It is found in penguin dung heaps, so that's one place, and anaerobic bacteria. So these are bacteria that don't need oxygen to live, and were probably very primitive bacteria. They were probably the first bacteria to come around because they didn't need oxygen, and on the very early Earth there was no oxygen. So these were the sort of first wave of life, probably. So anaerobic bacteria can certainly produce it, but only in reasonably small quantities. This is the announcement. It's a Nature item, as you can see, Nature Astronomy, and there's Jane Greaves as the principal author, and presumably these are some of her assistants at Cardiff. Here's Sarah Seeger, you can see, who had the idea to look for these combinations of molecules, and there's also Clara Souza on the paper, who did the work on how to detect phosphine. So why is it a big deal? Because, as I said, there's only these two things. We're pretty sure there are no penguins on Venus, although that has still to be proven. The problem is we can't think of any, or those in the know can't think of geochemical ways to produce phosphine gas. So that's an issue. There are sort of no known geological ways to produce phosphine just from the regular planet. That's not to say they're completely there aren't any possible ones that we haven't found yet, but so far there aren't. The other thing is that phosphine, if it is made just even briefly, is quickly mopped up by ultraviolet radiation and other chemical reactions in the atmosphere of would be mopped up in the atmosphere of Venus and also the Earth. It's split up by UV light and then combines with carbon from carbon dioxide or other things in the atmosphere. So it very quickly disappears from the atmosphere if you do make some. So this is one of the reasons why this is called a biosignature, is that you have to have something continually producing it. You can't just have a one-off hit and it will be just drifting around. So these are the two signals. This is actually from ALMA. You can see it's a much more precise measurement compared to the JCMT, which is much more blocky. And also with ALMA, because it has more precision, they can actually look on different parts of the planet, so they can compare the equator to the poles, and it seems much more prevalent around the equator than it does around the poles. So that's another clue. And whereabouts is it? It seems to be up here at about 50 to 70 kilometers above the surface. It's quite warm there, about 20 degrees C, so not a bad day. It's also a very reasonable place to be. It's only 1 atmosphere pressure. You can see much further down here, when you get to the surface, it's 90 atmospheres pressure. That's certainly enough to squash everybody flat. The problem with it being up here, though, is this is where the sulfuric acid that is notorious to exist on Venus lives, and that's particularly hazardous to life. So if you saw the Sky at Night special on Monday, they showed you pouring sulfuric acid over sugar and peas, and it didn't end well for either the sugar or the peas. So quite how life can survive in that, we're not quite sure. So that's pretty much all I've got. If there is life, we have to wonder where it did come from. We suspect there are oceans early on in Venus, and perhaps life moved up into the clouds, or maybe it developed in situ on the clouds, but that's a bit difficult to work out. The bottom line is this item from the paper that says the presence of phosphine is unexplained, and they've done exhaustive studies of steady state chemistry, photochemical pathways, and all sorts of other ways trying to produce or find ways to produce phosphine, and they can't do any of that. So we're left with, we don't know where it's come from. It could be bacteria in the clouds of Venus. It could perhaps be geochemical reactions that we don't understand, that we have no clue about yet, or it could be penguins on cloud base or something like that. So that's all I've got to say about that, and I'll answer any other questions in the chat, and we can get back to where we were.
Cool, thank you, Julian. Can you see the live chat? If anyone's got questions for Julian, do pop those in in the live chat. I've got Jupiter down on my C11 now, and I think James not far from Saturn. So I just have to switch computers because I've got it on the computer downstairs. So I'm just going to reclaim the host from Julian. So if you've got any questions, do send those through to Julian. Okay. So I'm just going to pop downstairs. I'll pick you up in just a few moments, and hopefully we'll get some views of Jupiter from the C11.
Okay, I can answer some questions here. If I thought I saw one earlier on about.
Okay, back at computer number 2. So I'm going to share screen. Cool. Okay, so I'm not at my machine now, so I can't check that's playing out, but I don't know if Julian or James could confirm.
Yeah, I can see that.
You can see that. Okay, so just a bit of info on the setup then. So this is linked up to a DSLR camera, so it's on a Canon D6. It's using the sort of the live view mode onto a computer. I don't know if that's better or not than the views we were getting from the C14, probably quite similar, I suppose. I certainly, through the actual camera, I reckon I can just about see the shadow of Io on there. I'm just trying. I think that box is probably just a bit in the way. So I'm just going to move the box out of the way.
Yeah. Could you make it any bigger?
Yep. That's just Zoom meeting control right in the way I don't want them to be, as usual. So just click on there. Oops. This should get rid of the box. There we go. So the box is out of the way now. Don't know if Leigh or James, and I reckon that is the shadow at the top of that mouse pointer. I don't know if anyone else can pick that out. If you do zoom in, it obviously looks a bit more hazy. There's a zoomed in view of that. See if we can recenter that.
Yeah, I can see something black there.
I think that's a spot of dust.
Yeah.
That one that's there is, isn't it?
I think
Yeah,
it's a
because
bit too
it's
stable.
not wibbling.
Yeah, it should be down here, I think, the shadow. So that setup is using a times 4 power mate on the C11, and then the DSLR camera linked up to that. So exposure-wise, it's on ISO, very, very high ISO. I think you want some quite high frame rate when you're doing anything planetary to get rid of some of this shimmer. So I've cranked the ISO up to maximum, and 1/25th shutter speed on that one. So that's the live view. You can see it bouncing around. That's just the shimmer you get from the atmosphere. Unfortunately, I'm looking straight over the roof of a few houses, which isn't ideal for the heat that's still being given off from the houses. So it's far from an ideal astronomy site, unfortunately. I don't know, just play around with the exposure bit. I don't know if we can bring out any of the moons. I'm not sure if I'm perhaps a little zoomed in. I think the moons are quite far wide tonight. Let's just see. I think we can see any. I can't make, just cranking up the exposure right now. I can't quite see any moons on there, I don't think.
Go on, crank it up a bit more.
What should we go to then?
Just keep going. Europa should be close, apparently.
Let's go up a bit more, see whether it will take it. So I drop the ISO a bit, do you think?
No, no, that should be all right.
Unless these are them here. Can't tell whether that's
Well,
dust, dust or not.
We can't see those. Well, I can't see that.
You're not? Okay.
Go on, crank it up even more.
Let's play with that ISO, see if we can do anything there.
No.
No, it's not having it. They did look on Stellarium. I don't know if Leigh can check that, but they did look quite far apart tonight. But I thought you'd probably be able to see them in that image. I think I probably can. It's probably just the output to zoom isn't quite good enough.
Physically take an exposure. See what that does.
Okay.
Drop it to 5 seconds or so.
Okay.
Yeah, and see what that does.
Let's put it into quick preview mode. 1 second. So that's just taking the image now. Might need to do that again. There you go. Oh, there we go.
Oh yeah.
So those are the moons then. That I think the resolution out to YouTube just isn't good enough to really pick up. But I can certainly see them twinkling on my screen and certainly on the camera. So yeah, there they are there.
So the near one is.
Which ones they are? Has anyone got Stellarium to have a look those?
Yeah, the nearest one is Europa.
That one there.
Yeah, and the furthest one is Ganymede.
Right.
And there's a star between Europa and Jupiter forming a triangle. Yep.
That one there.
That's a magnitude 10.5 star, apparently.
Okay. And that one just to the right. Is that presumably a star as well?
Yeah. Yeah.
Callisto's over to the east. I don't know if you can get that in the frame or not.
No, I probably can't shift it enough to pick that one up. Is there anything we can do with the exposure to try and see if we can see Io shadow at all, or is that just not going to be achievable?
No. But looking at Stellarium, it's so the shadow is the Europa side. And obviously Io is still the other side.
Yeah, I don't think I can see that on here at all. Anyway, that's a good example of the difference between using a DSLR and a planetary, I suppose.
You try a snapshot of that setting.
Yeah. Toned it down a bit on Jupiter, but you still can't. Let's just go a bit further down. Let's see what we get here. No, even on my screen, I can't make that shadow out. Do we want to have a look at Saturn? How are you fixed for?
I'm all poised, ready to go with Saturn.
Okay. I just need to go back to my other computer to switch that screen share, so we'll get on to Saturn in a second.
Julian, have you got any questions you can answer?
I've just replied to one.
Oh yeah. I can't see the questions, so
right.
educate me.
John Hurst. Maureen says, could there be penguins on Venus? So I suspect not. I think it's probably far too hot on Venus. It's about 450 degrees centigrade on the surface, something like that. So a bit toasty for penguins, really.
Has any other questions come through whilst I've been away? Can't see any there. I did see one earlier just asking about when the NAS Observatory is open. So I think
yes,
the answer to that one really is some time until we can get in with complying with the appropriate restrictions. We've not been able to go up there as members yet. So I think it's going to probably be some time before we can open up the site, in all honesty.
Cloud is encroaching on Saturn.
That was it? Okay. Typical. Do you
Um,
want me to give you control?
well, it's absolutely awful at the moment.
Right.
Richard, do you want to talk about the jet stream at all? I've got a good image you could possibly share.
Yeah, have you got that on your laptop?
Yeah.
Okay. So I'm just sent you control.
There we go. Hopefully you can all see the wonderful jet stream.
Yeah, so that's what's giving us a bit of grief tonight, I think.
Yeah, so you can see it's like a heat map of the jet stream. It's quite a nice website, this earth.nullschool.net. You can change all the settings to get various different views of the planet. I've currently zoomed in to just over the UK, and you can see jet stream is main body of it's to the north of us, but it is sweeping back round, back over the country. That's pretty sure that's going to give us some problems at the moment.
Yeah, I said it was Monday night when I think we were doing a few tests, and it was perfect. I've got one or two video captures of that, and some really decent seeing. It shows how it varies from night to night. Even just viewing from the same scope, the view can be completely different.
Absolutely.
Okay, do you want to give it a go and see what we can see with Saturn?
It's cloud.
Oh.
I mean, you can see the globe, and you can make out there is a ring, but it is pretty dire. But yes, go on, pass it over.
Okay, so that should be with yourself now, James. Yeah.
So, can you see?
Yep, that's on screen now, hopefully.
So it keeps getting a lot darker because the cloud is thickening up. In fact, looking out over the hedge, Jupiter's going. But you can see there's a globe of the planet, and then there's you could make out that there is a ring, and then there's a gaps between the planet and the ring. In fact, it looks like things are maybe.
I think I can make out just a bit of shadow from behind the disk of the planet onto the rings, onto sort of the top right as we're looking at it.
Yeah. Leigh, how much cloud is there?
Quite a lot.
Quite a lot, he says.
I can't actually see through my eyes.
Right. So while Julian was talking, we've put a red filter in front of the sensor to help steady the seeing, just a bog standard red filter. So that actually can it will block out other wavelengths, and that can help steady the image. And I think that has helped here. it brightens up because the cloud is clearing. I think so Leigh thinks it'll pass in about 5 minutes. So if you've got something else to do for 5 minutes, you could come back to us then.
Yeah, I can show you the view I had from Saturn the other night. That's quite a nice one. Let's get my system set up. I'll pull back the host.
It's quite chilly up here.
Sorry.
I forgot my gloves as well as the 9-volt battery. The things we do for the society.
Okay, so that's back with me now. So this is just some images of Saturn that I took when we were doing sort of some testing earlier in the week to try and get this all to work. So again, this is same setup that we're looking at through my Celestron C11 telescope of Jupiter. It's got a ×4 power mate, and then we're looking through a Canon 6D DSLR camera using the sort of the live shoot of that. So you can sort of see what view we're getting there compared to what James has just been looking at with the C14 telescope. Again, seeing was probably a bit better than I think this evening. I'm not sure how well that projects out over onto YouTube. It doesn't look quite as good quality as what I'm looking at. So just changing a few of the shutter speeds again, just to see if we can perhaps bring out some of the moons. So just going to give that a go. Use some of the camera exposure just to see if we can pull out some of the moons on there. Let's put the quick preview on. So there you go. You can see, so you see Titan there, just off to the right hand side as we're looking at it. Obviously, completely overexposed the planet to pull out that moon like we had to do with on Jupiter. I guess that just sort of shows to you how good your eyes are. The fact that your eyes, when you look through the eyepiece, can see the disks of the planet. You see the rings. You can see, sometimes cloud features, and you also see the moon. So it really does illustrate what a great job your eyes actually do to pick out all these features. Where with a camera, we're having to change the exposure settings to bring out sort of both aspects, taken to slightly different ways. So this is just a quick look at Stellarium, showing the what we're actually looking at on that still image there. So I'll just see if we can get that to zoom in a bit. There you go. So you can see the Titan off. So there is other moons, a bit more difficult to see actually on this view. I think I'll tweak the exposure again to see if we can pull out some of the smaller moons like Rhea and Dione. That you can just about see, and Enceladus that we had the talk on the other day is actually quite close to the planet. I think that's quite too much to pick out in this image, but if we have a bit of a play around with the exposure settings on the camera, hopefully we can tease out one or two more moons. So that's quite a interesting thing to try and see which moons you can pick out. So that's back now to the sort of the live view of it. You can see, I think, interesting here, looking how much more steady the seeing is. It's not bouncing around quite as much. Okay, it's bouncing up now. I've zoomed in a little bit perhaps, but just shows the difference in seeing from one night to another. So this is just taking some more exposures to change the settings just to see whether we can pick out any more of those moons. Put up that quick preview. Again, I don't know how well that's probably playing out to YouTube, but you can, on my view, see a few more of those moons there. So you probably wouldn't use this sort of setup for planetary imaging. You'd want a dedicated planetary camera, a bit higher frame rate camera. Sort of the one that James got, his ZWO camera is probably more what you would do imaging of planetary. But it's just, we thought we'd show tonight sort of the different types of cameras and what sort of views you can get. There we go. So that's Saturn through the DSLR. Has that given Leigh and James a bit longer to try and, is the clouds cleared for Saturn?
Yeah, they have done. Oh, they had done. Just having a. Well, I think this could be the last opportunity. So, do you want to hand back, and then I can show the view we've got?
Go on then, yeah.
So.
Well, that looks a bit better.
Hopefully, yeah.
Actually, fitting that, I'm just going to go and try and position my scope onto Saturn. So
Okay.
let's just take over for a bit.
So again, the brightness is altering because there's a thin veil of cloud. Well, it's not that thin actually, drifting in and out. But hopefully, well, he says, hopefully you can see again the planet and the rings. There was a hint of the Cassini division earlier. If we go back to Stellarium, there's Saturn. Every time it brightens up, it means the clouds have moved a bit. Let's center that on Saturn and go in.
Doing quite well, James. I've no view whatsoever of Saturn, just down the road from where you are.
Okay.
Not at all. I can't even see it through the eyepiece of my scope. So that just shows how bad the actual clouds have got.
So this, as Richard said, you can see the shadow of the planet being projected onto the rings behind there, which is a flipped version of that. Again, it's brightening up, so that means the clouds are shifting. And ideally, this black ring here is the Cassini division. And when it's more stable, you often get a glimpse of a dark ring. I don't know if it's just wishful thinking. I think it is sometimes, but other times you can see that. And then for images, so there's the Cassini division, that wide division there, and then there's this much thinner one, the Encke gap, and that's really a marker of a good amateur image if you can see that gap. But no, that's and that green dot is just an aberrant pixel, a hot pixel. But that's not I mean, with the red filter now, that's not a really bad view. Leigh, is Jupiter visible to the naked eye?
Barely.
Right.
No, it's not. I'm just looking out the window. I can't see.
No, further down the hill in Cotgrave, it's not visible. But I think we've done pretty well. Julian's seen 2 planets and he hasn't even left his desk.
That's how astronomy should be done.
Yeah, I mean, the view there, I would have a go at imaging that. In fact, we could do a capture, couldn't we? And then I can try and process it and send it to Roy for the journal. I might just have a little tweak of the focus. What's the cloud going to do, Leigh?
5 minutes
What, and then it'll be bad or
to be thinner,
thinner?
slightly thinner.
The focus isn't good. But I will process this and get it in the journal. Unless it's absolutely awful and I don't want to put my name to it. I always think it's amazing to think that that is nearly 1 million kilometers away. And we can see it so clearly, both distance-wise and also through our atmosphere. But at least we haven't got an atmosphere like Venus, which would include absolutely everything, certainly in the visible wavelengths. Richard, I don't think I can do much more. I could potentially go back to Jupiter with this red filter on.
Yeah, I can't get anything better from my scope. I can't even see it down here. So if you want to slow it over, then feel free. Probably worth saying, our meeting in November, we've got Damien Peach, who is probably the world-renowned planetary astrophotographer. So we should, I would imagine, get some good tips and hints on all of this imaging and possibly a bit more of the processing side of things from him, which should be good. So he's coming up in November. So
Right. I'm slewing to Jupiter. The scope seems to want to go the wrong way.
that's what you pay all that money for that mount for.
I can't do that. I haven't got enough lead length. I hadn't predicted it was going to. We were going to go on this late, so it's crossed the meridian, and I don't fancy going there.
Does the EQ8 do a meridian flip, same as the
Yeah.
EQ6? Yeah.
Yeah. It's pitch black, and I've got leads everywhere, and I wasn't prepared for a meridian flip, so I don't think I should do it.
Can you get on Mars? Has that come up yet?
Leigh, is Mars around? The scope's going somewhere.
Yeah, Mars is give it a try.
So Leigh's going to try and align the scope on Mars. We need a pack of emergency gloves at the observatory. or someone to make tea more often. Can you see it in the finder scope, Leigh? All right, okay, so that's hopeful. Nothing on screen yet.
Message from Jeremy says, even though the seeing's poor, take some images as Damien will make them look wonderful.
I don't even think Damien could make these look wonderful.
It should probably worth saying, I don't know if we mentioned it already, that Saturn and Jupiter are really quite low for imaging. They're not at all great. So I think Mars will be much better with it being quite a lot higher. A lot less atmosphere to cut through.
Oh, yeah. Let's have the controller, Leigh. We seem to have something. I think it's the lights on Cotgrave Police Station. Oh. That's it. That's Mars.
Let's leave it there.
It's very low.
Yeah, Mars, I think, is up for highest about 2-ish, isn't it, in the morning?
But this is nothing like the view we had the other night.
Mars is less than 10 degrees at the moment.
See if I can get it any better. No, I think we're going to struggle. Well, I'm going to struggle. So we could have a competition, say, guess the planet. But everyone would know that is Mars. Richard, Leigh sent you an image he's taken wide field with his camera.
Excellent. I'll try and get that up on the screen then. Yeah, I've got that image, so we can have a quick look at that before we finish tonight.
Have any questions come in?
Daniel Turner said a hat trick of planets, so it's not too bad.
Yeah.
I think it was about a month ago. It was possible to see them all in one night, wasn't it? I think.
Yeah. Well, we saw several of them.
Yeah, the Neo-wise evening.
Mercury, Venus, Jupiter, Saturn and Mars, I think.
I think Leigh and Gareth virtually saw them all, from memory. Fred says it's as blue as Neptune.
I think that's the red filter
Yeah.
having an impact. There's still quite a bit of cloud around here. Are you able to take the host back and look? Let's look at that image.
Yep. There we go. So we should have Leigh's image. That just taken with the phone camera, Leigh?
Yeah, it was.
Yeah. And what are we looking at in that image then?
Have you zoomed in a lot on it?
I think well, not massively, slightly.
Is that the image?
Yeah.
So is that
I sent 2.
there should be 2 images.
That's it, not
The later
stretched.
one was Jupiter and Saturn.
Well, I presume that I haven't seen them, so I presume that's Jupiter and that's Saturn. Is there another one? Have you got another image there?
I've not downloaded the wider field one at the moment.
Yeah, that's the nice one.
Okay.
It's got the hedge in the foreground. It puts it a bit into perspective. But yeah, I think that just shows the cloud which is passing through.
Another obstacle.
I'm just waiting for that other image to come down to us. Let's see if we can get that other image up. So that's Leigh's other image taken.
Oh yeah, that's yeah. So yeah, it's Jupiter on the right and Saturn on the left, and the observatory on the far right. Yeah, that's the view really we've got here, with the cloud.
Quick question coming on the live chat. Anyone use a Mac rather than a PC for astrophotography, for capturing and processing?
No, I don't.
Right. How do you do your processing, Leigh? Is that do you use Linux or those?
Leigh is detached from his microphone, I'm afraid.
Okay.
He does it all on Windows.
Right.
From reading the forums, there isn't a great deal of stuff on Linux for processing.
Processing what kind of images? Let me go back to the
Astrophotography, for both the capturing and the processing of the images.
He's gone again.
Question from Stuart Porteous. I don't know if Julian's still on the line. He asked, Julian, is there a list of proposed targets for exploratory probes that you're aware of?
For Venus, I don't think there's anything specific, but both the so there's a mission to Mercury at the moment called Bepi Colombo, which is already on its way there, but it's got several flybys of Venus to sort of slow down and get close to Mercury. So it's got to pass by that 20th of October, I think it is. So that one will be going past. And then there's also Parker Solar Probe. That will be going past Venus in February. Another close thing, another gravity assist to slow it down. So they just happen to be going past, and they have quite a few instruments on board, so you never know what they might be able to find. But nothing specific to Venus. Although there is a Japanese mapping mission at the moment around there that was supposed to get there in 2010 but missed, and but they caught it again in 2015. But I don't think any of these are really set up to look for life.
No, I wonder whether the discovery is kind of wrong-footed, a lot of the focus, because I think they're probably sending probes out to icy moons, aren't they, rather than to Venus. So I wonder whether it's going to swing it back the other way.
So Bepi Colombo is actually going to do a flyby of Venus to slow itself down before it reaches Mercury.
Yeah. So that's 15th of October 2020, so about a month away.
You never know.
You never know.
If you've got your mic back on, Leigh, this question might be for you. I think from Fred. Anyone in the society doing any Raspberry Pi stuff? I think Fred's quite into Raspberry Pis.
Yeah. If you bear with me, and I can get my camera. 1 second. Slow yourself down before it just move through. Yeah.
I'm more into chicken and mushroom.
15th October 2020, so about a month.
You never know. If you've got your mic back on, Leigh, this question might be for you. I think from Fred. Anyone in the society doing any Raspberry Pi stuff?
Someone got YouTube on. I can hear myself coming back.
Not me.
Yeah. If you bear with me, I can get my camera. 1 second. I'm more into chicken and mushroom. You got your mic back on, Leigh. This question might be for you. I think anyone in the society.
I'm just going to mute off Leigh because we're getting feedback on his mic. I don't know if he wants to come over to you, James, if he wants to share anything else.
He says, "Can you go back? He forgot to mute YouTube."
Right.
Yeah, apologies. There we go. There's me running around trying to get bits out of the car. So if I start my video again. Right, let me turn the lights on in the observatory.
Cool, that's fine. You can see it.
Right, I don't know. Maybe I have to see that. Let me get my torch on. This is a Raspberry Pi. I put together myself. You can see that. So we've got a camera on the nose. There's a Raspberry Pi underneath the back there. There's a daughter board with a battery on it, and that's all set up to do imaging. I haven't yet tried it in anger, but it's got the new Raspberry Pi high quality camera on it, so I can just show you that. Let's see. Wait a second. I can just get the. There you go. So you can see the chip. I've got a nose piece which we can pop on there, and that'll allow me to stick it straight into the telescope. All wireless. You can connect it to your phone to image with, and it will do video and stills. Is that the sort of thing that you're interested in, Fred?
It's impressive. Obviously, you're into computing and do it as a job. How accessible are something like a Raspberry Pi to the average user? What's your level of sort of computing knowledge to start?
I suppose it depends how much you're prepared to learn, really. I do Linux as a day job, so this sort of thing probably not too difficult for myself. But if you're not a regular computer user, or got a special interest in it, might be trickier.
Great. Okay.
Yeah. Oh, and as Fred just pointed out, the case is actually, I did 3D print that, so hasn't got a back on it anymore, because I added it did have a back on when I built it originally, but I've added this hat, as they're called, like a daughter board, which has got an onboard lithium battery, so I can get about 5 hours worth of life out of that. So you can use it as is. That at the moment is active. See the green lights on. That is running. So there is a quad core 4 gig computer in there. Quite fantastic, really.
Richard,
Cool.
I've got the shadow on Jupiter. It's not great, but it's better than it was.
Okay, you want to show us that? I've just sent the share request over.
Let me dim it down a bit. So can you see the shadow drifting in and out of focus there?
Yep. It's definitely not hot pixel.
It's not a hot pixel or a cold one or a dust bunny. So again, it's flipped from the image of Stellarium on the right. So it's on the other side. And as you can see here, Io is now off to the other side. So they're close. So Io should be over here. So let's brighten it up and see if there's any hint.
Oh, you can see it, yeah.
Yeah, you can see a little hint of Io there, which is good. So that kind of reinforces that waving dark spot is the shadow. It's a shame the seeing hasn't been better tonight. Looks like a solar flare.
It does a bit.
I'm freezing.
Good, yeah. Well,
Not good.
We've gone over our allotted time, so it was worth sticking with that just to see the shadow. And nice to pick that up again, just to demonstrate how the scene's changing, doesn't it? And the clouds coming and going. That sometimes you can see it, sometimes you can't.
Yep.
Right then, I'll probably wrap up. Let's bring the screen share back. Okay, so yeah, thank you very much to various contributions this evening, Julian, for filling in the gaps and allowing us a bit of time to fiddle with the scopes and talking to us about the phosphine discovery on Venus. That's really a good summary. And thanks very much to James and Leigh braving the extremes up at the observatory and the technology. To be honest, I think we did quite well getting that back via 4G connection, so not too bad at all. So thanks for bearing with us, everyone, tonight. I hope you found that interesting and saw what the different sort of views are like from different scopes, different cameras. So just to finish up, just a few notices on our next meeting. So the meeting for October, on Thursday, the 1st of October, we welcome back Steve Barrett. Steve came and gave an excellent talk to the Society last year on the Hale telescope. This time he returns online to talk about the legacy of the Hubble Space Telescope. So Steve really is an excellent speaker, so we look forward to that and hope you can all join us for that meeting. I've no idea what we're doing for Planetary in October. I don't think we'll perhaps give it a rest for doing more live imaging, but we'll keep you posted. That meeting's on the Thursday, the 15th of October. So we'll let you know what we plan to do nearer the time. So I hope you found that interesting. We'll see you all on the 1st of October. From me, James, Leigh and Julian, very good night.
Night.
Night.